Good morning. In this video, we are going to discuss about rolling friction or rolling resistance. In the introduction video of the friction, we have seen three important reasons for the frictions. The first one is the adhesiveness, and then roughness, and then deformation. The deformation occurs when any hard material is placed over a soft material. Okay, and this reason leads to the rolling friction between two surfaces. And moreover, this is the third type of friction. The first type is a static friction, second one is a sliding friction, and the third one is a rolling friction. Deformation plays a major role in rolling friction. Now let us go to the rolling friction or rolling resistance. The first one is, it is the resistance offered by the surface against the rolling motion. Okay. Then second important point is, it is due to deformation. As I already told, the deformation plays a very important role in the case of rolling friction between two matching surfaces. Then the third one is, the value of friction is less to static and sliding friction. As I already told, there are three types of friction: static friction, sliding friction, and then uh, ro rolling friction. And among these three, this will have the least value. Now consider a wheel of weight W and radius R, which is being deformed under this hard surface. So this is the hard surface and this wheel is deformed here. This is the value of del, which represents the deformation, the amount of deformation. Now since there is a contact between this wheel as well as this surface, there will be a normal reaction. So there will always be a normal reaction because of contact. Moreover, when I apply this force F, the wheel starts rotating, okay, and that will be prevented by this surface, and that prevention is nothing but this friction F. Now I am going to combine both N and F into a single force called resultant. This resultant will replace both friction and N. Moreover, this R will be minimum at this point and it will be maximum at this point A. So here is the representation of the resultant with respect to the normal reaction as well as the friction, and here this friction is nothing but rolling friction or rolling resistance. And we know that here by is the friction angle, which is the angle between this normal reaction as well as this R. Now I am going to consider this triangle ABC. Now from the triangle ABC, tan by, which is equal to opposite side, which is nothing but F suffix R, and by adjacent side, which is nothing but normal reaction. So here it is F R by N. But from this one we can get the answer for rolling friction, which is nothing but F R equal to N tan by. But we know that coefficient of friction equal to tan by, where by is nothing but friction angle. Now in the place of tan by, you just substitute the value of mu. Finally the rolling friction will become like normal reaction as well as the coefficient of friction. Now this is the point A about which I am going to take the moment. Now you just check how many forces are presented here. The first one is the applied force F, weight of the wheel as well as this resultant, but there is no distance, perpendicular distance between R and A, so naturally it will become 0. Now we are going to find the moment about this point for these two forces. Take moment about A, summation of MA equal to 0. Now you see here, this is the moment point, and if you consider the weight, okay, this is the weight and here is the perpendicular distance D. So W into D, which is the moment of this W with respect to point A, and for F, okay, the perpendicular distance is this one, that is the distance between O and B. Okay, so here it is written W into D minus F into OB equal to 0. Here it is given as minus. Okay, I assume that the clockwise moment is taken as negative and the anti-clockwise moment is taken as positive. So W into D is the anti-clockwise moment, so it is here, it is positive, and F into OB, okay, here it is the clockwise moment, so it is minus, equal to 0. But it is not rule, you can even change the order also. Now in the place of OB, you see here the radius of the wheel is R, so distance between this O and this point is R. But we know that the distance between B and this end is del, so this distance is now R minus del, so that's what here it is written. Now if this del is small, then the above equation will become like W into D equal to F into R. From this equation, you just get the answer for D, which is nothing but F dot R divided by W. Now in this equations, the variable D is nothing but the coefficient of rolling friction. So in the case of rolling friction, they will ask you to find this coefficient, and here is the formula: applied force into radius of the wheel divided by weight of the wheel. Then moreover, this rolling friction formula F suffix R equal to N into mu, where N is nothing but normal reaction and mu is the coefficient of friction. So in the case of rolling friction or rolling resistance is concerned, these are the very important informations. Thank you. We will meet in the next video.